Okay, so we're going to talk about direct variation, how to write an equation, how to solve a direct variation problem, and then we're going to talk about your Hoy and Vux lines and some reminders for those two special lines that you have. So direct variation, it's a proportional relationship. So you remember it passes through the origin and its slope is constant, and how you find the slope is taking your y value divided by your x value. And again, your y-intercept is 0 in your y equals mx plus b equation. So it's really going to be y equals mx, and then because b is 0. So we have an example here. The distance a jet travels varies directly. So varies directly is going to be your look for your clue words. This is going to tell you that it is direct variation. So the distance a jet travels varies directly with the number of hours it flies. A jet traveled 3,420 miles in 6 hours. So if you remember that time is an x value, they're saying that x equals 6, which makes 3,420 miles your y value, 3,420. So now if I want to find my slope, my m, it's going to be y divided by x, 6. So let me get my calculator here and clear the memory. So if I do 3,420 divided by 6, my slope is 570. If I got a decimal, I would just change it to a fraction, okay? So my equation is going to be y equals 570 times the value of x, and that's going to tell me how many miles I travel. All right, estimate how many hours it will take to fly 6,500 miles. So how many hours? So they are telling you that x equals question mark, and they are telling you that your y value is 6,500. So y equals 6,500. Okay, if it is a varies directly problem or direct variation problem, you can solve it by using a proportion. So a fraction equals a fraction, 2 equal ratios. So we're just going to set this up. I'm going to say 3,420 miles over 6 hours. And now I'm going to set up my other side, other ratio. And miles has to be in the numerator and hours in the denominator because of how I set up my first ratio. So I'm going to say 6,500 miles over x hours. And we're going to cross multiply. I make an x. If two numbers are connected with an x, those are the numbers I multiply. So I'm going to say 6 times 6,500, and then the number that connects with x, that is the number you divide by. So I'm going to say 39,000 divided by 3,420, and my x, the time that it will take, is about 11.4 hours. Now, if I wanted to use my calculator, I could go to y equals, and I could type in 570x. And since this is a y value, I'm looking for 6,500 in my table. That's 1,140, 1,700, 3,300, 2,290, 2,850, 3,420, 3,000. So I'm going to keep going. There's 5,700, 6,270, one more. Okay, so here I was under 6,500. Here I was over 6,500. So my x value that I need is going to fall somewhere in between 11 and 12. Which it does. All right, equations of lines. So now we're going to talk Hoy-Vux, and we're going to talk parallel perpendicular. Parallel lines have the same slope. That is what is important. Same slope because the lines lean the same direction. That slope is what causes the lean. So if my slope of my first line is positive 2, that means the slope of my second line has to also be a positive 2. If the slope of my line is a negative 2/3, the slope of my other parallel line has to also be a negative 2/3. They're the same. They have to match so that they have the same lean. Perpendicular slopes, however, have opposite reciprocal slopes. Okay? Because they meet at right 90-degree angles. So if the first slope is 1/3, my second slope is going to be the opposite sign, so a positive, and reciprocal means you flip the fraction. So it's going to be 3 over 1. 3 over 1 is just a whole number of 3. All right, so if my slope is a positive 2, for my other perpendicular line, I have to change the sign, so it's going to be negative, opposite in sign, and then a reciprocal. Well, this is not a fraction until I put this over 1, and now when I flip it, it's going to become 1/2. So that's how you deal with perpendicular lines. That's how you match up their slopes, even though they don't match. Hoy lines, remember they're horizontal, your slope is 0, that's what the O tells you, and it's a y equals equation. Okay, 0 slope, they're parallel to the x-axis because remember the x-axis is horizontal. Vux lines, vertical, U stands for the slope, undefined, x equals the equation. Okay, they are perpendicular to the x-axis. The x-axis runs horizontal, perpendicular would be running vertically. All right, so let's look at these couple of questions. So I have a line parallel to the x-axis. Well, if my x-axis is like this and it has to lean the same way, that is telling me it is a hoy. So my slope is going to be 0, m equals 0. Okay, if the slope is perpendicular to the x-axis, so my x-axis runs like this, perpendicular would be a y, so that would be a Vux line. And my slope is the u, m equals undefined. Okay, what is the slope of the line parallel to the y-axis? Well, if the y-axis runs up and down, so does my other parallel line, which makes that a Vux. So what is the slope of a Vux line? That's what the u tells me, and that tells me my slope is undefined. Okay, what is the slope of a line perpendicular to the y-axis? All right, well, if my y-axis is running vertically, perpendicular would be, it has to be a hoy line. So what is the slope of a hoy line? Well, that's what that O tells me, and that is supposed to represent the slope of 0. All right, let's look at these last 3 examples. Write the equation of a line in slope-intercept form. That is y equals mx plus b. And it is parallel to this equation. So it has to have the same slope. Well, what is the slope of this line? And because it's in y equals mx plus b format, I know that my slope is -3. So my new slope for this second line, the line that's parallel to this one, also has to be -3. And I know it also has to go through the point 3, 6. So what I'm going to do is I'm going to use my point slope equation, and I'm going to say y minus the y value is equal to the slope times x minus the x value. And so I'm going to distribute. So that's going to be -3x plus 9. And now I'm going to also move over this -6. And when I do that, it has to have a sign change. And then I have to combine like terms. So I'm going to get y equals -3x plus 15. Now what I'm going to do is I'm going to go to my calculator, because I always want to check in my calculator if I have an equation. I'm going to go to y equals, and I'm going to clear this out, and I'm going to type in the equation we got, -3x plus 15. And I know my slope is -3, so this checks out. Check, check. What I want to check is, does this equation, does this function have this point in the table? So I'm going to second graph, and I'm going to check. I'm going to go to the point. X is 3, is my y value 6? Yes, so it does have the point I'm looking for, so I know this is the correct equation. Go ahead and clear this off. All right, write an equation of a line in standard form. Okay, if they're asking you to write an equation in standard form, here's what you need to do. You need to rearrange answers. Check points in table and check slope. Y equals mx plus b. Okay, so what you want to do is your answer choices are probably going to be in standard form. So you're going to have to rearrange those answer choices. All 4 equations need to be arranged to slope intercept, y equals mx plus b form. Then you'll know your slope. Then you'll be able to check any points they give you in the table. So we want our slope to be perpendicular to this, which means I have to take the opposite reciprocal. Okay, well, what's my slope of this line? The slope of that line is -3. So m equals -3, I have to now change the sign. So my new slope is going to be positive, and I have to flip the fraction. That's what reciprocal means. So if I flip 3/1, it's going to become 1/3. So I know my slope has to have 1/3. And it also has to have the point 3, 6. So we're going to use point slope. We're going to plug in 6 for my y value. We're going to plug in 1/3 x minus, and then we're going to plug in our x value of 3. So we got to distribute. So we're going to get 1/3 x 1/3 times 3 is 1. So it's going to be minus, it's 1/3 times a -3, which would be -1. And now we're going to move this 6 over. And when I move that 6 over, it changes to a +6. So a -1, and then we're adding 6 to that, is going to be 5. So my final equation is going to be, I'm going to write it over here, y equals 1/3 x plus 5. Now, again, I'm going to check my table. I'm going to go to y equals, and I'm going to type in my equation. If I know that it shouldn't match, so I shouldn't have the same fraction, shouldn't have the same slope, which I don't, x plus 5. Now I'm going to go to the table to check my point, and it's the 0.36 in my table, and it does check out. So there we go. All right, write an equation of the line that is parallel to the y-axis. So if it's parallel to the y-axis is like this, so my line also has to go up and down, so that's a Vux line. And it has to pass through the point 3,2. Okay, so I know that I better not pick any answer choices that have y equals, so I can eliminate those answer choices. I'm looking for the answer choices that are x equals, because that's how you write a Vux line equation. Okay, so now I got to think, x equals, well, what does x equal in this point? Is it 3 or is it 2? And hopefully you said 3. So whenever you have a point, you always pick the x or the y value for whatever your equation is. If it's y equals, you would pick the y value. If it's x equals, you pick whatever the x value is, and that is your equation. You cannot graph Vux lines because you don't have an x equals button. You only have a y equals button. So you could have checked the Hoy line in your calculator. Hopefully this helped, showed you how you can use your calculator to help you with direct variation and Hoy, Vux, perpendicular, and parallel lines.